Hey guys, I'm Andrew from Lampro Event Solutions. Welcome to our third online sound training session that will be focusing on the first and most common type of processor in the sound system, namely the mixing console. Please remember to follow us on Facebook and to subscribe to our YouTube channel to receive updates for all the future sessions that will be coming up. If you're already subscribed, make sure to hit the notification bell to stay updated about our latest videos. As mentioned in the previous sessions, Lampro Event Solutions specializes in technical services for the events industry, and we're a supplier and installer of professional sound, lighting, AV, and staging equipment. If you need any of these services, including live streaming or video recording and editing, please send me a message or visit our website at www.lamproaudio.co.za. We make use of professional brands including Allen & Heath's analog and digital mixing consoles, as well as other processors that include Radial Engineering and DBX. Our range of speakers include Turbo Sound, Behringer, and Wharfedale. In the previous session, we used Shure, Audix, and Sennheiser microphones as examples. If you're wondering why I included some of the entry-level brands, it was mentioned previously that some of them can be used very effectively to get professional results. If you're a professional and experienced sound engineer, you can use a lot of these and still make it sound good. I'll be posting a review shortly where I'll compare some of the entry-level mics to the expensive ones, so make sure to look out for this. I'll be using a basic analog mixing console, the Allen & Heath Z12 effects, as a reference during the session. As always, the theory behind these sessions will be applicable to all makes and models of professional mixing consoles, so please use your own mixer for practical purposes. Here are some of the references that I'll be using during the online sound training sessions. Firstly, the Yamaha Sound Reinforcement Handbook. That's a good source of theory that covers various topics when it comes to sound reinforcement. The second reference is the Soundcraft Guide to Mixing that's available at soundcraft.com, which is applicable to this session. The third one is Microphone Techniques for Live Sound Reinforcement that's available at shure.com, and it was used in the previous session. The fourth one is Loudspeaker Basics from electrovoice.com that will focus on different types of speakers and their applications. The fifth one is 10 Key Tips for Better Sound from behindthemixer.com. And then lastly, the Alto Pro Live Sound Guide from the Alto Professional website, which will give you a general explanation of sound from start to finish. All of these guides are available for download in the video description below, so feel free to make use of it. Right, so let's get going with the third session of the online sound training course that will focus on mixing consoles. In session 2, we discussed different types of microphones and their polar patterns, which is the first link in the sound chain. The second link in the chain is known as signal processors. The mixing console is the heart of any sound system where the most important processing takes place. In the session after this one, we will look at other types of processors, including compressors, limiters, gates, and effects units. We'll cover digital mixing consoles more closely in session 4, since these processors are built into digital mixing consoles. The mixing console that I'll be using in the next session is the Allen & Heath SQ6. You probably saw it behind me in the previous sessions. Here's a short video to give you a taste of what you'll be looking at in session 4. Okay, I have to be honest, I'm a bit of an Allen & Heath enthusiast, and I'll always recommend their mixing consoles above any of the other brands out there. They are very well priced and packed with features for anybody that might want to switch from analog to a good quality digital mixing console that won't cost you an arm and a leg. Before the SQ6, I made use of the affordable QU24, which is an exceptional digital mixing console. It's real value for money that none of the other brands can beat at this stage. The SQ6 is a compact but powerful 96K mixing console. It has 24 local inputs and can be expanded to a total of 48 input channels by making use of Allen & Heath's range of digital stage boxes. The console itself is loaded with features, processors, effects engines, and it's deep processing ready. If you want to get a closer look at it, make sure to join me in the next session. Today, we'll start with the basics of signal processors and mixing consoles, and I'm using the Allen & Heath Z12 effects for reference. Signal processors in sound systems are devices, for example mixing consoles, that change the characteristics of an electric audio signal in the following ways: preamplification, input sensitivity attenuation, equalization, audio level attenuation or volume, compression, and amplification. We will discuss mixing consoles in more detail to cover preamplification, input sensitivity attenuation or gain, equalization, and audio level attenuation or volume. Any mixing console, regardless of its size or capabilities, can be described as the heart of the sound system. A mixing console is a complex audio device that processes audio signals by means of preamplification, gain adjustment, and equalization. Once the processing stage is complete, the channel's audio signals can be routed to several outputs, namely the master or main left and right outputs, as well as mix outputs that can be assigned to groups, auxiliaries, or matrices that is applicable to digital mixing consoles. Analog mixing consoles usually have auxiliary and group outputs on them that the channels are already assigned to, that is applicable to auxes, or that they can be assigned to, that is applicable to groups. Analog mixing consoles are available in different frame sizes, starting from as small as 2 channels all the way up to 48 channels. Some analog mixers also feature built-in processing, for example effects units, graphic EQ, and compression. This cuts out the need for external effects, compressor, and graphic EQ processors, making the mixing console more versatile. There are mixing consoles that also feature built-in amplification. This allows the mixing console to be connected directly to passive speakers without the need of an external amplifier. These units have basic functions and is used when a 2-speaker sound system is adequate. Right, that covers the basic functions of a mixing console. Here follows a few examples of analog mixing consoles, starting with the Allen & Heath Z6 mixer. This is a basic 2 mono, 2 stereo channel mixer. As you can see, you have 2 mono and 2 stereo inputs in the input section with basic functions including gain, EQ, pan, and level adjustment. This mixer features 1 main output, the left and right master outputs. Next, we have the Allen & Heath Z12 effects with 6 mono and 2 stereo inputs. It has the same functions as the previous mixer, but also features built-in effects, 4 auxiliary outputs, mute and PFL or pre-fade listen buttons, and faders for level adjustment. The EQ section is also a little more complex. We'll use this mixer in a practical demonstration shortly once we had a look at other examples. The next example is the Allen & Heath Z22 effects that has all the same functions as the Z12 effects but features a lot more channels with 16 mono inputs and 3 stereo inputs. The following mixing console is the Allen & Heath Z436. This mixer features 32 input channels, a bigger EQ section, 6 auxiliaries, as well as 4 group outputs. Right, that gave you a good idea of what the different analog mixers look like. As the frame sizes get bigger, the more functions they have. In the next session, we'll cover a few examples of digital mixing consoles to see how their functions and features are different when they are compared to analog mixers. Next, we'll look at the functions of an analog mixer in more detail, followed by a practical run-through. Right, let's have a look at the analog mixing console's channel section. Right at the top, you'll find the mic input, and that's a balanced XLR input that has a built-in preamp that is mostly used for microphones that produce low-level audio signals. The line input below it is a balanced TRS or jack input that is used for various instruments and playback devices that produce high-output audio signals, for example, keyboards or media players. The insert below it is a TRS connection that is used to connect external processors, for example compressors, to that designated channel. The gain below it is a rotary fader that is used to attenuate the incoming audio signal, ranging from -6 dBus to +63 dBus for mic-level audio signals, and -10 dBus to +26 dBus for line-level audio signals. The 100 Hz switch is a switch that is also known as a high-pass filter, and this will cut all frequencies below 100 Hz. This is useful for vocals or any other instrument that does not produce frequencies below 100 Hz. The HF, or high-frequency 12 kHz rotary fader, is a rotary fader that attenuates all high frequencies above 12 kHz. This EQ is known as a shelved parametric EQ. If the rotary fader stays in the middle, the audio signal remains flat. Rotating it clockwise will boost the frequencies above 12 kHz from 0 dBs to +15 dBs. Rotating it anti-clockwise will cut the frequencies from 0 dBs to a -15 dBs. The MF section in the middle is a set of two rotary faders that is used to attenuate mid-frequencies between 120 and 4 kHz. This EQ is known as a sweepable parametric EQ. The black rotary fader is used to select the desired frequency, and the blue rotary fader is used to cut or boost the selected frequency, ranging from -15 dBus to +15 dBus. The LF, or 80 Hz rotary fader, is a rotary fader that attenuates all low frequencies below 80 Hz. This is also a shelved parametric EQ that works in the same way as the high-frequency shelved EQ. Right, guys, as we go further down the channel section, we'll get to the auxiliaries, the pan, the mute and PFL buttons, and the linear fader. Right at the top, we have the auxiliary section. AUX1 pre is a rotary fader that is used to send the channel's audio signal to the AUX1 output. The overall level that is sent to the AUX1 output is controlled by the AUX1 master in the master section. A pre-fade auxiliary is not affected when audio levels are attenuated by means of the channel fader. Pre-fade auxes are mostly therefore used for monitor speakers on stage. AUX2 pre is a rotary fader that works exactly the same way as the AUX1 rotary fader. AUX3 post is a rotary fader that is used to send the channel's audio to the AUX3 output. When audio levels are attenuated by the channel's fader, the audio signals that are sent to AUX3 will also be adjusted accordingly. FX post is a rotary fader that is used to send the channel's audio to the built-in effects unit. This AUX is used for the built-in effects unit, but the built-in effects can be bypassed when the FX post output is used. The pan is a rotary fader that is used to sweep the channel's audio signal to either the left or right master output, or both. When the pan rotary fader stays in the center, the audio signal is sent to the left and right master outputs. Sweeping the pan rotary fader to the left or right will send the audio signal to either left or right outputs accordingly. The mute is a switch that is used to mute all incoming audio signals from being sent to the designated outputs. The PK, or peak LED, is a red LED that will flash when the incoming audio signal is distorting. This means that you need to lower the gain to prevent the distortion. The PFL button is a pre-fade listen button that is used to monitor the levels of the incoming audio signals on that channel. The audio level of the selected channel will be displayed on the mixing console's VU meter in the master section. The linear fader, or channel fader, is used to attenuate all audio levels that are sent to the main and post-aux outputs. These faders are primarily used to mix the sound that is sent out of the main outputs to the main speaker system. Right, let's have a look at the analog mixing console's master section. If you have a look at the top in the center, you'll see the main inserts, or the inserts for left and right. These are balanced TRS jack connectors that are used to connect external processors, for example, graphic equalizers and compressors to the main outputs. The main outputs or main out left and right outputs are balanced XLR outputs which sends the audio signal from the main mix to the main speaker system, which can be active speakers or a power amplifier that's connected to passive speakers or a recording device. The mono out is a balanced TRS output that is linked directly from the main outputs into a mono audio signal that can be used for additional speakers or a recording device. The alt out or alternative out is an unbalanced RCA output that is linked directly to the main outputs that is usually used for studio monitor speakers or a recording device. The aux 1 to 3 outs are balanced TRS outputs that sends audio signals from the designated auxiliary that can be used for additional speakers, and these are usually stage monitor speakers or a recording device. The phone's output is a stereo TRS output that is used with headphones to monitor audio signals that are sent from the main outputs, aux outputs, or individual channels via the PFL feature. The USB send and return. The USB send can be used to send audio signals that's linked from the main outputs or aux outputs that can be selected via the 3 black switches. When using it as a USB return, audio can be sent from an external device to a stereo channel. The 48-volt switch. This is a switch that activates phantom power for condenser mics and active DI boxes. And the VU meter. This is a LED meter that is used to measure and monitor audio signals that are sent to the main outputs. It can also be used with a PFL feature to monitor channel audio levels. As we go further down the mixing console's master section, you will find the phone's rotary fader. This rotary fader will adjust the audio signal that is sent to the phone's output. The aux 1 and 2 switch is a switch that allows the phone's rotary fader to be used to monitor the audio signals that is sent to the aux 1 and aux 2 outputs. This is also known as AFL or after fade listen. The 2-track return switch allows the phone's rotary fader to adjust the audio signal that is sent from the 2-track return. The USB return switch allows the phone's rotary fader to adjust the audio signal that is sent from the USB return. The alt out is a rotary fader that adjusts the audio signal that is sent to the alternative output. The alt LR switch is a switch that will determine if the alternative output is routed directly from the main mix or if the alternative rotary fader can be used to adjust the audio level that is sent to the mono output. The LR pre or post switch. This switch will send audio from the main mix in either pre or post fade mode. In pre-fade mode, the main left and right faders will not affect the levels that are sent to the alternative outputs. In post-fade mode, the main left and right faders will affect the levels that are sent to the alternative outputs. The aux 1 and 2 masters are a pair of rotary faders that will adjust the overall level from all the channel's audio signals that is sent to the designated aux outputs, namely aux 1 and 2. The main left and right faders are a pair of linear faders that adjust the overall sound mix that is sent from all the individual channels to the main outputs. The main outputs are connected to the main speaker system or a recording device. Right, so that gave us a little bit of a theoretical background on the workings of an analog mixing console. I'm fully aware that not all analog mixing consoles make use of the same names and abbreviations, but at the end of the day, all of them work the same. They all use the same principle. Next, I'll be going into a practical demonstration to show you how all of these functions work. In front of us here, we can see the Allen & Heath Z12 effects, and this is a good quality standard analog mixing console with 6 mono or mic channels, 3 stereo channels, and the effects unit that's also built into this mixer. You can see on channel 1 at the moment, I've got my microphone connected that's being used for the recording with the gain that's been set properly, the EQ that's been set, and the fader at the bottom is open that will send the audio from this channel to the master outputs that's being used for the recording. From the onset, it's always important to remember to have all of your gains set up properly. Regardless of how many mics or instruments may be connected to any of the inputs here, whether it's the mic inputs or the line inputs, you need to make sure that your gains are set correctly in order to get the correct audio levels coming into the console. If the gain has been set up too high, you might end up with distortion, and if the gain has been set too low, you might not have sufficient audio being passed through into the channel that needs to be sent out to your outputs. So how do we set up a gain properly? Well, just to give you a demonstration quickly, if we hit the PFL button on channel 1 that's being used with my microphone, or the pre-fade listen button, you will actually see on the VU meter here the audio signal that's coming into the mixing console on that specific channel. Since the gain has already been set properly, I don't have to worry about any distortion taking place, and there's sufficient audio that's being sent out at the moment to the recording that you can also see, because the gain has been set correctly. I'm not going to do any adjustments to channel 1 because that's being used for the recording, but I already have another audio source that's connected to channel 2, and we're using a 1 kHz test tone for practical purposes. If we hit the PFL on channel 2, you will see that there's no audio that's being passed into the channel, but that's only because the gain has been turned all the way down. So once we go to the gain on channel 2 and we turn it up, you can see that audio is coming into that channel. At the moment, it's a little bit too high, so what I'll do here is I'll just turn it down a little bit till we reach approximately 0 dBs. This is always a good level to set for any incoming audio signals into any of your channels, whether it's the mic or line inputs, to leave yourself sufficient headroom for any fluctuations that might take place with the incoming audio signals. This commonly happens, with vocal mics or instruments where there might be fluctuations in the audio levels. So always try to set it as close to 0 dBs as possible to leave yourself some headroom in case the audio levels increases. Okay, so once we've set the gain properly, we're basically ready to see or to hear what the audio sounds like when it's been sent to the main outputs. So from here, I'll unselect the PFL, I'll unmute the channel, and since we're using a 1 kHz test tone, when I open the fader, you'll be able to hear the tone that's being sent to the recording. And the fader can be adjusted accordingly to get the right level for that audio signal on that specific channel. Right, next we'll have a look at the equalizer section of the mixing console, and this is known as a parametric equalizer. On channels 1 to 6, you've got a high shelved, a sweepable mid, and a low shelved EQ, and on the 3 stereo channels, you've got a high shelved and a low shelved EQ. The reason why the 3 stereo channels make use of a smaller EQ section is because the 3 stereo channels are usually used for playback devices where there's not a lot of EQ required. Right, so let's have a look at the EQ setup on channel 1. Since I can't do a lot of adjustments on channel 2 with a 1 kHz test tone, we'll use my microphone as an example. You'll see the HF shelved EQ at the top is in the center position, which means that no adjustments are taking place. The mid-sweepable EQ section have a certain frequency selected at 500 Hz, and it's being cut with -4 to -5 dBs to get rid of the mids there at the moment. And the LF shelved EQ at the bottom is also in the center, which means that no adjustments are taking place on frequencies that are 80 Hz or below. I'm just going to give you an example of what it will sound like when we adjust the high frequencies above 12 kHz. So if I turn it clockwise, you'll hear a lot of those high frequencies come through a lot clearer. If I take it back to the middle, it remains flat. And when I turn it anti-clockwise, you'll hear all the frequencies above 12 kHz being cut in the process. And it makes it sound a lot more muffled. It's not that clear anymore. The sweepable mid gives you the option of selecting any frequency from 120 Hz up to 4 kHz. And that adjustment will be made with a black rotary fader, so you can actually choose any of the frequencies that's giving you a problem, and then the fader below it, the rotary fader, the blue rotary fader, will give you the option of either cutting it or boosting it. So let's start right at the bottom at 120 hertz, and I'm going to cut it out all the way. Now you'll hear what it sounds like when 120 hertz is being cut out, and when I actually change to the different frequencies, you'll hear what it sounds like when the different mid-frequencies are being cut as I go along, all the way up to 4 kilohertz. So that gives you a good idea of what that will sound like with the mid-frequencies or the different mid-frequencies being cut out. Let's put it back to the position where it was originally. So if we go from here and boost all the mid-frequencies, you will also hear the opposite effect. Let's start right down at 120 hertz. And when I actually boost them, you're going to hear a significant difference in the way that the mid-frequencies respond, all the way up to 4 kilohertz. And let's put that back where it was before. Right, and the low frequency shelved EQ is also center with no adjustment taking place for all the frequencies above 80 or below 80 hertz, sorry. But if I cut out all the frequencies below 80 hertz, you might hear that it sounds a lot more tinny with less bass coming through, or low frequencies if you want to use the correct terminology. And once we actually boost it and turn it clockwise, you'll hear a lot more of those low frequencies coming through. But because I'm using the 100 hertz switch at the top there, the high pass filter will actually cut all the low frequencies below 100 hertz. So maybe let me just undo the 100 hertz high pass filter. And if I actually adjust the low frequencies now, you'll hear it sound a lot tinnier or a lot thinner. But if I boost the bass or boost the low frequencies, you'll hear a lot more of those low frequencies coming through. Next, we'll have a look at the auxiliary section on the mixing console. Here we've got two pre-fade auxiliaries, namely aux1 and aux2, and we've got two post-fade auxiliaries, namely aux3, and the effects post-fade auxiliary that is specially assigned to the built-in effects unit. Traditionally, you'll always use your pre-fade auxiliaries, aux1 and aux2, for stage monitors that will not be affected by the channel's fader, and aux3 or post-fade auxiliaries will be used with recording devices that will be affected by the channel's fader. I'm quickly going to give you a demonstration of what the different auxes sound and work like. At the moment, I've got a speaker connected to the aux1 output, and if we open the aux1 master, and the aux1 rotary fader on the designated channel where we've got the 1 kilohertz testing tone. You can hear some of that coming through the speaker, but when I adjust the fader, you won't hear any difference to the overall level that's being sent through to the speaker. It stays constant, it always stays the same. And that's why you would traditionally use this for stage monitors, where musicians don't want their audio levels that's been set to their speakers to change according to the faders, that's being used for the main sound system. If I quickly change at the patching to aux3, which is a post-fade aux, and we open aux3, the channel's fader needs to be open in order for it to be sent through to the aux3 output. As you can see at the top there, it's connected to aux3. In this instance, aux3 does not have a master, to be adjusted accordingly in the master section. But as the channel fader is adjusted, whatever is being sent to aux3 will also be adjusted. If I turn it down, it will be a lot softer. And this is traditionally used for recording devices, so that if you've got certain mics at a lower level or a higher level that is similar to your main outputs that's being sent to the main sound system, the recording device will receive the audio levels accordingly. Next, we'll quickly have a look at the built-in effects unit. Now, the effects post auxiliary on each channel works exactly the same as the aux3 post auxiliary. So any levels that might be adjusted with the channel's faders will also have an effect on the levels that are sent to the built-in effects unit. I know that the effects unit here is probably not visible to you, but here you've got a couple of parameters that you can select, different types of effects that you can select. And let's go and select, let's see, a whole reverb. On the next bank there, hall 1. So we've got a whole reverb selected at the moment. And if I actually open the post aux on channel 1 where my microphone has been patched, and I open the effects master, you'll be able to hear the effects being sent to the recording. If the effects post auxiliary is closed, it won't send anything. If it's opened again, you'll hear the effect. But if the aux master is also closed, you won't hear any effect. Next, we'll quickly have a look at the pan feature. And the pan is used to send the channel's audio signal to both the left and right outputs when it remains in the center. If you want to send the channel's audio to left and right separately, you'll turn the pan anti-clockwise to send it to the left-hand side, and you'll turn it clockwise to send it to the right-hand side. The mute switch here will switch the channel's audio on and off, which basically means that any channel that is muted will not send audio to any of the designated outputs, whether it's the main outputs or the auxiliaries. When the mute switch is activated, it does not mean that there's no longer audio coming into the channel. It's simply not passing audio to any of the outputs. The PFL button, as explained before, is used to monitor the audio signal that's coming into each one of the channels, and that can be monitored via the VU meter at the top here. You can also use the pre-fade listen feature to listen to the audio via the phone's rotary fader when a pair of headphones is connected to the phone's output. The master faders at the bottom here will control all the levels that are sent to your main outputs, which in turn is connected to a speaker system or to a recording device, depending on how the mixing console is being used. So all the levels that are adjusted and that's being sent from your faders on the console will go to your master section and will be sent from here to the main outputs. From here, the aux1 and aux2 masters will control all the levels that are being sent from the auxiliaries on each individual channel to the designated aux outputs. And the alternative rotary fader will control all the levels that are sent to the alternative output that is directly linked to the main output. The phone's rotary fader will control the levels that are sent to the headphone output that you would like to use for monitoring. And the 48-volt switch there at the top is used to switch phantom power on and off for condenser microphones and DI boxes. Right guys, that brings us to the end of our third session of the online sound training course that covered the first type of processor, namely mixing consoles. In the next session, we'll briefly have a look at other processors such as DI boxes, graphic EQs, and the dynamics processors that are also known as compressors, limiters, and gates. From there, we'll go into the practical side of things by using the Allen & Heath SQ6 as reference. Please remember to like and to follow us on Facebook, Instagram, and Twitter, and to subscribe to our YouTube channel for all the upcoming sessions. As always, if you have any comments or questions, please leave them in the comment section below. And thank you. I will see you soon.